like I said, we'll do some together, and whatever we don't get to in class, which will probably be about half of the worksheet or so, the rest will be the assignment for homework. So number 1, let h of x equal f of x times g of x. So already my antenna are up for product rule, probably, where the graphs of f and g are given below. Evaluate h of negative 2 and h of 3. So h of negative 2, well, h is f of x times g of x, so that means f of negative 2 times g of negative 2. By the way, you got to write really small if you want to fit it all in this worksheet, because they ask like 4 questions in one line, and you got to make it work. Or you could get a separate page out and do it on that. Alright, so f of negative 2. Now I don't have an equation for f where I could plug in negative 2, but I do have a picture of f. So based on my picture, what is f of negative 2? Can you tell by looking at the picture?
1.
F of negative 2 is 1. So 1. And then g of negative 2 is 3. And so my answer is just 3. So not bad, just using the picture to answer the question rather than an equation. H of 3 is the same thing, but we're going to skip it and find f prime of negative 2. So skip to B. And it says estimate rather than evaluate. That suggests that our answer will be less precise than part A. So find f prime. We've got a bunch of them to find. F prime of negative 2. Well, I've got negative 2. How do I find f prime? What is f prime in terms of the graph of f? It's the derivative, but what is the derivative in terms of the graph of f?
Slope.
The slope. So I need the slope at negative 2. So I think now I know why it said estimate, because people are going to draw slightly different slopes on how they lay their tangent line on there. I mean, it should be close, right? That's not a tangent line, and that's not a tangent line, but something in there should be my tangent line. And so that slope should tell me the derivative at negative 2. And I happen to hit that one pretty close to an easy slope to find with the grid on there. So slope is, rise over run. So we went down 1 over 1. That worked out pretty nice. So my slope at negative 2, slope of the tangent line is negative 1, which means the derivative is negative 1. And again, estimate because your tangent line might be a little bit different than mine. F prime of 3. So the slope of f at 3. So there's 3. I think it's helpful to sketch it on there, so grab your ID or some other straight edge. Sketch it on there. Let's see. What do you think? If we go down 1, or if we go over 1, how many down did we go? Maybe that's the best way to say it. If we go over 1, so if our denominator is 1, our change in x is 1, What's our change in y? I think so. I think we managed to make that one -1 as well. Again, it's approximate, so last period I didn't quite go down that far. I ended up like 0.8 down or 0.7 down. But that's okay, it says estimate. G prime of -2. Alright, so I'm going to press pause, and why don't you find G prime of -2. We'll compare our answers, but they might be slightly different, and that's okay. Again, I got 0.8 because I would go up 0.8 and over 1. Again, it's easiest to go over 1 and then just count how many up or down you went. All right, we'll speed it up a little bit. Find G prime of 3. Draw the tangent line on there. The slope, let's see, if we go over 1, we would go up a half. 0.4 if we want to try to get technical, but yours might be 0.6 or 0.7. So I think a half is fine. And you could write it as 0.5 or 1/2, either way. Questions on that? It's just using the graph. It's not hard stuff, just a little bit different than we've done before. Part C, H prime of -2. Okay, well, H prime, the derivative of H, that's where I have to use the product rule. Now, instead of putting all the parentheses, I'm gonna shortcut it and say FG prime plus GF prime. FG prime plus GF prime. And I think we've already found all the pieces. So let's look back through our answers. At -2, and this is where I messed up first period. There's just so many numbers floating around. F of -2. F of -2. Oh, we haven't found it yet, but on the graph, F of -2 is 1. Go overboard in color code here. G prime at -2.
0.8.
We said 0.8. Again, that's where we could have slightly different answers there. Plus
G of -2 is 3.
G of -2 is 3. And then F prime of -2. Right? Yeah, F prime of -2. F prime of -2 is -1. So, well, we could safe stop and just leave it as that. 0.8 minus 3, -2.2, but safe stop. We're good. I'll leave you to find H prime of 3. Let's skip down to number 2. I guess the longest number 1 ever is 1, 2, 3, 4, 5, 6, 7, 8 parts to number 1. Number 2. Let h of x equals f of g of x, where the graphs are given below. By the way, it's the same graph, so you can use some of the same information for f and g. So pay attention.
No, chain rule.
Chain rule. F of g of x is the chain rule. So maybe even before we get started on this thing, I'm going to want to write out what h prime is. H prime would be, okay, one layer at a time, outside in. So f prime of g of x, and then chain that onto g prime of x. But first, let's back up a second. H of -2. So that means f of g of -2. Let's see, g of negative 2. So I've got to go to the graph. G of negative 2 is 3. So that becomes now the input to the f function. F of negative 3. So now I'm looking at the f graph. Uh-oh, did I mess them up?
It's just
Oh, it's positive 3. Yes, yes, thank you. Thank you. Grumble louder next time, so I'll catch the mistake sooner. So f of 3. So now I need to look at the graph of f when x is 3. Yeah, and again, it's like, it's 0.5. It's probably close enough. So 0.5. H of 3 would be the same process. Why don't you... Yeah, we got time. So g of 3 is negative 1. F of negative 1.
I'd say it's 0.4 to 0.5.
0.4, 0.5, 0.3 even. Something along those lines. I'll go 0.4 because it looks lower than half. Question B. Is h prime of negative 3 positive, negative, or 0? Explain how you know this. Well, the explain is going to be using the chain rule. Thank you. And I guess they said positive, negative, or 0 because we know there's some estimations going on here. So if we just keep it to positive, negative, or 0, we should probably all end up with the same answer. So you might get 1.7 and I have 1.8 or 1.5, but if by narrowing it down to positive, negative, or 0, we should be okay. So h prime of negative 3. Okay, so here's my formula for h prime down here. F prime of g of negative 3 times g prime of negative 3. So I've got to use the graph, 3 different times here. 2 of them for slopes. So carefully, I've already made one mistake. So g of negative 3
is negative 1.
Wait. G, when x is negative 3, is 2. So I'll need f prime of 2 times g prime of negative 3. So I guess it doesn't matter which one of those I get first. So I need the slope at 2 of f. So again, you got to make sure you're looking at the right graph, the right x value, and either the y value or the slope there. So it's a lot of things to keep straight. Like none of them are that hard to do. It's just make sure you go to the right graph, look at the right x value. Ooh, what's the slope of f at 2? 0. Ah, that saved me a little time then. Because
no matter what you multiply it by, it's going to be 0.
Exactly. I was trying to figure out how to ask that question where the answer is, it doesn't matter. What's the slope at negative 3 of g? Well, it doesn't matter, because if we multiply by 0, we're going to get 0. So I don't have to, I'm glad I found the f prime slope first, because that made the second part irrelevant. Why don't you try part C? Remember, we're only worried about positive, negative, or 0, so you don't have to be super precise on finding some of these. So f prime at 3 is negative. But we'll just be really lazy and just say that it's negative, because that's all I really care about at this point. The slope at 3 is negative for f. the slope of g at -1, slope of g at -1, the slope is, what's all I really care about the slope of g at -1? It's negative. And two negatives, if we're multiplying them, makes a positive. So h prime of -1 is positive. All right, the back is similar, kind of similar to some of the test questions we had. So I think the test had one very similar to, I think there was a quotient rule that was, yes, no, do you remember? I think it was the quotient rule, or was it the product rule?
There was a product rule and a quotient rule.
Okay. Let's see, we did product rule earlier, so let's do the quotient rule one. So h prime is gf prime minus fg prime over g squared. And it wants us to find h prime at 2. So this is just a matter of picking off the right value, putting it in the right spot. So g at 2 is 4. F prime at 2 is 5. Minus f of 2 is 3. G prime is -2. G is 4, so 4 squared. And safe stop, leave it alone, be done. B would be the product rule. H, you would just have to add them together, right? The guy in the video referred to the sum rule, but it's just you sum them. That's not hard. Number 4. So what rule is going to be involved with number 4?
Product. That's how we chain.
Chain. Be careful. That's not multiplying. That's f of x, or f of g, or g of f. I want to do h because that looks weird. F of f. I guess in some ways it's easier because if you get them backwards, it's still f. But this outside f will take the derivative of, and then multiply it by the derivative of the inside f, even though it's the same f. So I don't know if that makes it more confusing or less confusing. So f prime of f of 2 times f prime of 2. All right, there are more numbers involved here. So what's f of 2?
5.
5. The x value is 2, f value is 5. So I need f prime of 5 and f prime of 2. So again, I'm just looking at the table. Who knows what equation gave us these answers, but that doesn't matter. F prime at 5
Pi times e
is pi. And f prime at 2, f prime at 2 is e. So yes, my answer is pi times e. Again, we don't really care the exact answer. We're concerned with the process of putting those pieces together. All right, 5's a little more complicated. It's the same stuff. It's just there's more numbers, so you got to be more careful. And we'll stop at 5. So 6 through 11, you don't have to worry about. You can stop at 5. So it's just using tables, using graphs to find derivatives. There's like 3 main areas that they want you to be able to do calculus from. Calculus from tables, that's this. Calculus from graphs, that's the front. Calculus from equations, that's what we do most of. but that's not, you can't do everything at once. So everything will be either from an equation, from a graph, from a table. Focusing on graphs and tables today. All right, again, your job is to finish through number 5. Some of you probably already have.